In this question now, the following interaction is proposed between proton and the pion. The quark content of the pion negative is U bar D, and the quark content of K negative is given as U bar S. Three conservation rules are considered: the baryon number, charge, and the strangeness. Which conservation rules are violated in this interaction? Okay, so let us see. First of all, I think the baryon number is clearly violated here because the proton is having a baryon number as +1. Pion is 0 because pion's content is given as U bar D, so it is like meson, and for the mesons, the baryon number is equal to 0. This is K, and even this is a meson because one is a quark, another is anti-quark. So for this also the baryon number is 0, and this is pion plus, so that is basically UD bar, and so it's kind of anti-particle for that. So even this is 0. So clearly the baryon number is violated here. Number 2 is charge. Let us try to see what is happening with the charge now. So the charge goes like this. This is +1. This is -1. This is -1. This is +1. So charge is conserved. And what about the strangeness now? So the composition here is given, like for proton, we know it is up, up, down. And for pion negative, it is given at it is anti-up and down. So there is no strange quark on the left hand side of the reaction. But on the right hand side of the reaction, there is this K minus, which is having strange quark there. So the strangeness for the strange quark is taken to be -1. It means that here it is -1, here it is 0, 0, and 0. So strangeness is definitely not equal. Like on the left hand side of the reaction, it is 0. On the right hand side of the reaction, it is -1. And so definitely even the strangeness is violated here. So the answer given here, because like it is 1 and 3, so answer given will be B. But I have one thing to add here, and that is strangeness is not a conservation principle. Like its strangeness usually changes, and when the strangeness is lost, like in the reactant part, there is a strange quark and it is converted into something else. At that time, the reaction is possible still. Even when the strangeness is violated, even then the reaction is possible, but it becomes a weak reaction. So it takes more time, and so weaker nuclear force interaction is taking place there. So the reaction rate becomes slower. It takes like nearly 10 raised to the negative 10 seconds or something, but the reaction is still possible. So I know like the answer will be B because there is no option is there that says that only number 1 is the correct answer, by the way. But there is no such option. So we will definitely go for option B. But strangeness is not a conservation rule. There are 3 conservation rules. One is baryon number, another is the charge number, and another is the third one is the lepton number. These are the 3 conservation principles. Strangeness is not conserved. It may or may not be conserved. So you people can make sure of this information that I am claiming with your teachers. You can talk to them and you can ask for this particular question, am I right or not? So you can confirm it once. But this is what I believe, that strangeness is not a conservation rule. But still, the answer for us for this question is B. Let us see the mark scheme. What is the answer given? Clearly, the answer given is B. So this is the true explanation of what is written here. And thanks for watching the video. This is Professor Varun. Please subscribe to the YouTube channel. It's very important. And also, you can join the YouTube channel if you want better services, like you can access the paper 2 questions, and I might be floating a crash course soon. Anyways, all the best. Bye.